In example number 7, we need to find the area of the region bounded by the graph of f of y equals y squared and the y-axis between 0 and 1. Now, this one's different than the one we did before is because it is a function of y, not a function of x. Now, we can still graph this. So let me get this graph. Now, remember this is basically x equals y squared. So if you solve it for y, this is the square root function. Okay, so we know what this is going to look like. It's going to look like this, which we don't need that part of it. Okay, and we are going from 0 to 1 in the y direction. So it does go through this point 1, 1. But this is the area we're trying to find, this area right here. Okay, so when we go to draw our triangles, or not triangles, rectangles, our rectangles are going to go this direction. Oh, not like that. Our rectangles are going to go this direction. Okay, they'll be in the y direction. So the process is going to be the same, except everything's going to be in terms of y instead of x. So we still want to find the area by taking an infinite number of rectangles. So as n approaches infinity. So we're going to take all of those rectangles, the area of all of them, and add them together. And it's f of ci. And instead of delta x, it's going to be delta y because we're in the y direction. We still need to figure out what delta y and ci are. Okay, so remember delta y is going to be b minus a over n. So in this case, a and b are 1 and 0. So our delta y is 1 over n, and that's the width of each of these rectangles here. Okay, that's how wide it is. And then we also need ci, which is going to be a plus I delta y. Remember before it was delta x. So a is 0. So we have 0 plus I, and we just found that delta y was 1 over n. So we get I over n. So we'll come over here and plug that stuff in. We're taking the limit as n approaches infinity of f of ci is 1 over n, and delta y is 1 over n. All right, so now what we want to do is plug in f of I over n. Okay, here's our function, so we're going to plug that in. So we're going to plug in I over n into our function. So we get I over n squared times 1 over n. Now we'll just clean that up. So our numerator is going to be I squared. Our denominator is going to be n cubed. All right, now that we've gotten this, we want to clean this up so we can use one of those formulas from page like 291 or whatever. So we are going to pull out 1 over n cubed, because remember that's a constant. N is some sort of really big number, like 100 million or something like that. All right, so we get this. So we have the limit as n approaches infinity, 1 over n cubed. And then we're going to take a look at this part right here. This, we can use one of those formulas from page, I think, 291. Should be in your notes. But the summation of I squared, that one is n plus 1, 2n plus 1 over 6. All right, now it's time for some algebra. I am going to go ahead and cancel one of those n's right now because I can. So in the numerator, I'm going to FOIL that out. So we get 2n squared plus 3n plus 1 all over 6n squared. Now I'm going to split it into 3 different fractions. So 2n squared divided by 6n squared is just 1/3. And then 3n divided by 6n squared, let's see, that's 1 over 2n. And then we have 1 divided by 6n squared. All right, now I've got this all cleaned up. I'm going to plug in infinity, because remember we're taking the limit as n approaches infinity. So that first term is just 1/3. And here, if we plug in infinity, 1 divided by 2 times infinity, that's just going to be 0. 1 divided by 6 times infinity squared, that is also going to be 0. And so our answer is 1/3. Okay, so back up here, this picture that we drew, this area here in blue is exactly 1/3. So I wanted you to see this example that you can do these areas in terms of x's or in terms of y's.